Welcome back to another episode of How to Algebra, where we are continuing the conversation about graphing rational functions using the acronym R.A.T.E.Y. Today is the third part where we are looking at top-heavy situations during the E step in R.A.T.E.Y. So if their degree in the numerator is larger than the degree in the denominator, you're going to use either long division or synthetic division to figure out the formula or the equation for the oblique asymptote. So let's get it. All right. R.A.T.E.Y. day 3, or part 3 rather. So we're looking at top heavy situations. So number 1, see if we can factor the top. Two numbers that multiply to make 2 that add up to -2. And we cannot. So we can't factor anything. It doesn't factor clean. So we run through our checklist. Set the top equal to 0. And we said that we can't factor it. So we would have to use the quadratic formula, right, when you can't factor it. So negative b plus or minus b squared minus 4ac. All right, so if you notice, the discriminant, the part inside of the square root, is going to come out to 4 minus 8, which is going to be a negative number. So we can't take the square root of a negative number. So this means that there's no x-intercepts. There's no x-intercept. Set the bottom equal to 0. We're going to get x is equal to -2. So there's a vertical asymptote at -2. So -2, there's a vertical asymptote. We analyze to see if there's any square factors in the numerator and the denominator, and there's not. I couldn't even factor the numerator, so how could there be a squared factor in the numerator? So no. In the bottom, again, no. All right, we compare the numerator, the degree in the numerator, to the degree in the denominator, and we see that it is top heavy. So for a top heavy situation, we have to use either long division or synthetic division, whichever one is more suitable for the situation. I personally like synthetic division. So I'm going to use -2, right? Because we're setting the divisor, right? The denominator, the part that's being divided into, we set that equal to 0. So x plus 2, right? X plus 2 is equal to 0. And so x has to equal -2. So that's the number that goes in the box. Then we grab the coefficients of the numerator, and we start going through our synthetic division process. -2, -4, 8, 10. So we actually don't care about the remainder. The part that is important to us is that y equals x minus 4. So in a balanced situation, when the degrees match, numerator and denominator, you take the ratio of the coefficients. In a bottom heavy situation, the horizontal asymptote, that's what we're referring to, the ratio of the coefficients tells you the horizontal asymptote. The bottom heavy situation, the horizontal asymptote is y equals 0. All right. In a top heavy situation, it's not a horizontal asymptote, but it is an asymptote. It's a slant asymptote or oblique asymptote. It's basically non-horizontal. It's a dotted line, an asymptote that the ends of the branches will go towards, and it's not horizontal. In this case, it's a line that is y equals x minus 4. So 1, 2, 3, 4. So -4 is where it crosses the y-axis, and it's basically a 45-degree line, right? Because the slope is 1, 1, up 1, over 1. All right, and the y-intercept is you set x equal to 0. And we see that it's going to be 2 over 2, which is basically 1. It's going to cross the y-axis at 1. All right. Since it has to cross the y-axis and the ends have to tend towards the asymptote, that's what the upper branch would look like. The other branch is going to be down here. Now, if we wanted, we could plug in 3, -3, to get a negative value, which would be down here. All right, so the big takeaway from here, if you're following through the other videos, part 1 and 2, all we're doing is we're adding a top-heavy situation where we have to use synthetic division. See another example. Okay, so again, the numerator, we try to see if we can factor, and we see that we can't. So then when we try to set the top equal to 0, we're going to see that it is going to be the same situation as the last example, where the discriminant is going to have a negative number. So there's no x-intercepts. All right, the bottom equal to 0, x is equal to +3. So there is a vertical asymptote at x equals 3. There's no square factor in the top or bottom. And it is top heavy. So that means we have to use synthetic division. So x equals +3, then 2, 1, 1. Bring down the 2. 2 times 3 is 6. You always add. 21, you always add. Again, we don't care about this number. So this is going to be 2x plus 7. So the horizontal asymptote, or in this case, the oblique asymptote, is going to be y equals 2x plus 7. So 1, 2, 3, 4, 5, 6, 7. So up 2 over 1. So it's going to be more vertical. All right. Y-intercept is going to be 1 over -3. So -1/3. So this is 1. It's going to be here. Okay. The graph is going to come down towards the asymptote, cross at the y-intercept where it's supposed to. And then the other branch is going to be up top. More or less something like this. And as always, you can always plug in 4, +4, to get an actual value for the upper branch. So you may be saying, like, how do I know that the branch is up here? Well, there's 3 possibilities where it could be. Where I drew it, off to the side, and off to the other side. So if you think about the other 2 sides, there's no x-intercept. And not only that, but the bottom is answers no. So the branches have to be opposite of each other. Right? For it to be on either one of the sides, that means that it would cross the x-axis, and then it would tend towards the it would tend towards the asymptote. So it's not either one of those, right? And then the left side, it would cross the y-axis at 2 spots instead of the 1 spot. So it can't be left and right. And it can only be the upper one. All right, number 3. It's already factored, so that's nice. All right, we're going to set the top equal to 0. So this is going to be x is equal to negative 1/3 and negative 2. So at x equals negative 1/3 and x equals 2. Negative 1/3 and 2. Negative 2. That's where it's going to cross the x-axis. So at the bottom equal to 0, negative 1, there is a vertical asymptote at negative 1. X equals negative 1. Okay, there's no squared factors in the numerator. So that means it's going to cross at both x-intercepts. There's no square factors in the denominator. So that means that at the asymptotes, that the branches are going to go opposite of each other. The degree in the numerator is greater than the degree in the denominator, so it's top heavy. So we're definitely going to have to do some synthetic division. For that to happen, we're going to have to distribute the top. So it's going to be 3x squared, 6x, 7x, plus 2. All right, so x equals negative 1, then 3, 7, 2. So the oblique asymptote is going to go through 3x plus 4. So up 3 over 1. Okay, the y-intercept is going to be when x is 0. So 1 times 2 over 1, which is basically 2. So when y is 2, that's where the graph is going to cross. So this looks crazy. So the arrow, the end, has to be close to the asymptote. It's going to cross, and again be close to the asymptote. And then it's kind of wild. It's kind of wild. Okay. That's 3. All right, let's look at 4. Let's see. We always try to factor first. So 2 numbers that multiply to make 6 that add up to 1 somehow. So 3 and 2. So this is going to be positive 3, negative 2. Factor in the bottom. 2 numbers that multiply to make 8 that add up to 6 somehow. So this is going to be negative 4, negative 2. So right away, x minus 2 cancels. So we know that wholes cancel. And that there's a whole at x equals 2. So at x equals 2, there's a whole. So it's kind of like clean up what we got. After you cancel, you always want to collect all the leftover pieces and see what the actual function looks like. So y equals x minus 1, x plus 3 over x minus 4. All right, when the top is equal to 0, x is going to be positive 1 and negative 3. So at negative 3, it's going to cross or bounce, and at 1, it's going to cross or bounce. We'll determine that in a later step. Denominator equals 0, x equals 4. So at x equals 4, we have a vertical asymptote. All right. We look to see if there's any square factors in the numerator and denominator, and there's not. Then we look at the end behavior, a horizontal asymptote that the ends may tend towards. So this is going to be, so we look at the factored version, and it's top heavy. So let's distribute x minus 1 and x plus 3. So this is going to be x squared, 3x minus x, 2x, and then minus 3. So 1, 2, negative 3. And then in the box, we have positive 4. All right, bring down the 1, multiply, add, multiply, add. Again, we don't care about the remainder. What I care about is x plus 6. So y equals x plus 6. That is the oblique asymptote. So 1, 2, 3, 4, 5, 6. And it's going to go, slope is 1, so a 45-degree angle, right? Up 1 over 1. And the y-axis, or y-intercept, is when x is equal to 0. So negative 1 times negative 6 over 8, which is positive 3/4, right? 6 over 8, 3 over 4. So about right here. I feel like, let's see, 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. I feel like the oblique asymptote is not correct. Okay, so you probably saw it already. It's going to be because the vertical asymptote is not in the correct spot. Let's go. Two, three, four. Okay, this looks mo better. All right. So, right, because you always got to kind of like look and see how how the graph looks, right? Because the ends have to go towards an asymptote for sure. So when the vertical asymptote was on the other side, this branch right here that I'm now drawing had nothing to go towards. And then the upper branch. Okay. Number 5. Can't be factored. It's already factored. When the top is equal to 0, x is 0. So it's going to cross at the x-axis. And by default, or intuition, it's going to cross at the y equals 0, or the y-intercept at 0 also. Kind of going out of order. All right. So then when we set the bottom equal to 0, we have 3. So x is going to be positive 3, negative 2, negative 4. Again, it doesn't really matter the order. So at positive 3, for sure positive 3, there's a vertical asymptote. At negative 2, there's a vertical asymptote. And then 2, 3, 4. At negative 4, there's a vertical asymptote. So right away, we have 3 vertical asymptotes, which means we're going to have at least 1, 2, 3, 4 branches, if not more. Okay. Is there a square term in the top? Yes, there is. And it's at 0. So at 0, we know the branch is going to bounce. So we know it's going to bounce. That's what answering yes to the top means. The bottom, there are none. So at the vertical asymptotes, the branches are going to be opposite of each other. So it's kind of nice to know. And this is bottom heavy. So in a bottom heavy situation, we know it's y equals 0 is the horizontal asymptote. And again, notice that the horizontal asymptote goes through the x-intercept. So this is very normal around the origin. It's the ends out towards infinity where the branches cannot cross, right? But around the origin, it is perfectly normal for it to cross the horizontal asymptote. Okay, so let's figure this out. So I need to plug in a value for x that's going to give me some information around the origin. So I'm going to do 1 when x is 1. When x is 1, we get negative 1 on top. 1 minus 3, negative 2. 1 plus 2, 3. 1 plus 4, 5. So I'm going to get a positive number. That's really all I care about. It's because negative over negative cancels. So I'm going to get positive 1 over 2 times 3 is 6. Times 5 is 30. So when x is 1, y is 1/30. So this means the branch has to go up like this. Not only that, it has to bounce at x equals 0. So it's going to have this parabola looking branch. And that's very useful because we know that at every asymptote, the branches have to be opposite of each other. So right away, if that side goes up, this side has to go down. And not only that, but this side has to come from down. It can't cross the horizontal asymptote, so it has to turn around and come back down. If you don't believe me, we can plug in 1, 2, 3. We can plug in 3, and we'll get negative 3/2. I've actually done the math on that one. So it would be in between 1 and 2. And then the last branch has to be opposite. Let's go. It's kind of interesting, right? This is a fun one. After you get all the information together, it's almost like a puzzle. All right, see if you can do the challenge. Okay, we set the top equal to 0, x equals -1, and also positive 2. So -1, positive 2. Bottom equals 0. Vertical asymptotes are going to be at -3, positive 3, positive 1. Positive 3, -3. 1, 2, 3. Okay. Is there a square term in the numerator? Yes. At x equals -1, it's going to bounce. Now, think about what else is in the numerator. X minus 2. So then at x equals 2, it's going to cross. It crosses. For the bottom, so technically, like, the bottom was a no, or so for the top, right? There's a yes and a no. There's a yes at -1, and then the other no, the non-squared term or squared factor is no, right? X equals 2. The graph crosses. So looking at the bottom, there's 2 squared factors in the denominator. At x equals 3, technically it's -3 if we're going in order. At that vertical asymptote, right, that's the most left one, it's going to, the branches are going to be together. At positive 3, they're also together. And then at 1, they're going to be opposite. So up until now, we've only seen like 1 or 2 terms, if not 1 term. Well, really, we've only seen 1 term in the bottom. Either way, you have to consider all terms. That's the point. Every term can't go unnoticed. And how many x's do we have on top? So we're comparing, right, the degree. We have potentially 3, like x cubed on top over x to the 5th. So this is definitely bottom heavy, which means y equals 0. This is our horizontal asymptote. Y equals 0. No, the y-intercept when x is equal to 0. We're going to get 0 plus 1 squared, which is 1, times -2 over 3 squared, which is 9, -3 squared, which is also 9, times -1. And this is going to be -2 over -81, which is positive 2 over 81. So if this is 1, it's going to be very close to the x-axis. All right. With that being said, we have all the information we need. So at 1, right, at 1, -1, we're going to bounce. So it's going to cross, come up, come to the left, and up towards the asymptote. Okay. Check it out. At x equals 1, at x equals 1, do it in red. They have to be opposite of each other. The branches do. So that means it's got to come from down here. And when it goes to the x-axis, at 2, it has to cross. Right, it crosses at 2. So it's going to cross and go towards the other asymptote. All right. At positive 3, they're going to be together, the branches. So that means if it went up on the left, it's got to come up on the right. And then last but not least, at negative 3, they're also going to be together. So if it goes up on the right, it's going to go up on the left and then down towards the asymptote. So there it is. It's kind of interesting. Hopefully this helps someone out. So just remember, it's just like parts 1 and 2. The only difference is the top heavy situation. All right. Good luck.